So can I? Okay. Okay. Hello, everyone. Today is in the morning. In this room, there's like to trust or to test workshop. So hopefully you are all waiting for this. And sorry for delays. We had some small problems. I want to start from. Hold on. It's not the end of the problems. Okay. So I want to start from a small introduction. So I'm Dorota Jarecka. I work for McGavin Institute at MIT, and I have PhD in physics. And
I'm Jaruga, and I work at Caltech, and I also happen to have a PhD in physics.
So we actually met at university in Poland, and so as you can see, we don't have really like a proper background in computation, but we do have like a lot of experience working with codes and working with codes that are written by people who also didn't have experience, and definitely the code didn't have any tests. And we kind of like after a few years of PhD, I couldn't be more sure that like having tests is nice. Like, you know, like when you have like 30,000 lines of code and no single test that you can run whenever you are changing any single line, that is actually, I have some small nightmares about this. So, so because we are like 60 people, I think like it will be like slightly too long to introduce each of you, but maybe we can find like your friend for like next 3 hours, and you can just introduce to each other and just tell what you are doing, etc. Because also we wanna work in pairs during the day, so or 3 people, whatever. So maybe you can just start introducing to each other.
I mean, you can code by yourself, but we encourage discussion and collaboration.
So we will give you like a couple minutes for this. To się nie podwiększa. Tylko to się nie powiększa. Tu bez... Tak, ale wiesz co, chwilowo bym usunęła. Okay, that's great that you already found your body for this course. So, okay, I don't have to shout right now. So there's a problem always like with like providing the first link, so you can like copy paste the other links. So as the first link that you will have to type we just provided this to the Etherpad, so we will be using during the time of the tutorial. So can you please type the link here, and you can here, like on the right hand side, you can put your name, and to see if it's working. So during this, like the course, we will be like maybe copy pasting here something. Maybe we will ask some questions. So the first question we have that we wanna test you the if everything is working, you can put your name. You can answer this question and put your name on this. Yes? Even large. Okay. Yeah, I made. So as I said, like the first link is the hardest. Okay, we have like 37 people still. We're missing some. Hmm? Sorry, it's _1, sorry. For whatever reason.
Sorry, can you read the link out, please?
Yeah, sorry. Oh, okay. So maybe I actually should have started from small explanation. When can you use this note sticky notes? Whenever you have some technical issue, you can just put your pink one on the laptop, preferably like this, so we can see you. And whenever, like doing exercises, if you are like done with the code, you can put the yellow one. So if anyone is having like any issues right now with the link, you can just put the pink one, and Anya will come and help you. Okay, so we have
also, like if you have any questions, feel free to ask, interrupt us at any time. This is meant to be a very hands-on workshop, so.
Okay, we have like 52 people. Is it more or less anyone is having issue? Okay, so I will make this slightly smaller. Nice. So we do have some experts in the room. That's good. So feel free also like to comment and to add anything you think would be useful. I'm happy that you are a minority. So, okay. So, so what you can also see on this pad, we put a link to presentation and to GitHub repository. So hopefully you did receive my emails before the tutorial. So and hopefully everyone has Git. Is that right? Nice. Again, if you're having any issue, just put the sticker. So if you go to this repository, we would recommend that you do fork first. And if for whatever reason you don't have Git or GitHub, we can help you with this also, like during break. It's not like crucial right now. But we just want to make sure that it's working. So once you do fork, from your repository, you can clone it. So to clone it, you can just you will just change the name. Oh, sorry. Is this big enough? Okay. Okay, so yeah, I will come back to presentation. So we already and I will have like some more setups just to check if everyone has like proper environment, so we don't have to wait at the time that we have like exercises actually. So okay, so we already introduced ourselves. So just to have like, is it the newest version? Sorry, I have so many versions that I got lost. So I want to quickly go through the learning objectives during this tutorial. So we want to focus on testing, and we don't only want to give you tools, but we also want to provide some motivations. So we want to explain why do you want to write tests, what are the types of tests you might want to write, what are the testing framework in Python, and we focus on PyTest. And at the end, we also like cover continuous integration. So again, like doing like in the email, I ask you to have to prepare Python environment. So hopefully, like everyone has. If not, you can also like now, install Conda and prepare the environment. One thing that is so important that you have Python 3.7, 3.6 is fine, and that the version of matplotlib is also like 3.0. Also, like hopefully everyone has like text editor, like whatever you like to use. If you don't have, you can always like also install Jupyter and use the text editor from Jupyter. This is like just in case you are not prepared for like you don't have everything on your laptop. So if you need to install anything, like this is like in the slides, so you can just copy paste and read this. And now I will continue with the presentation. So so why do we test software? So first of all, like there's like simple like observation that people make mistakes, and either you are like beginners or advanced, like you will make mistakes. And this is like, even if you are like huge company and you have like the very best programmers, you still like can have like, you still can mess up with people's life because you make mistakes. So this is like one of the famous like glitch from Amazon in 2007 that some people ended up not being able to turn on the light. And the simple story behind this was like just one guy was making maintenance on Tuesday, and like a few mistaken keystrokes, and like everything like escalated. So what Amazon said at the end was that they modified this tool and they added some safeguards to prevent it. So as you see, like they didn't say that, oh, we have this one stupid guy that we have to fire. But basically, like they know that mistakes happen, and you have to just add like safeguards. And that's more or less adding tests is one of the safeguards that you can have. Not the only one, but it's a very important one. And this is also like from different domain, more like because we are both scientists, maybe closer to us, is that also like in scientific world, there's also like there are some famous story that people had to retract article from Science only because they changed the sign somewhere, and no one checked this, no one noticed, and they built career on the code that it didn't work properly. So in addition to making mistakes and avoiding them, it also like makes you think about desirable output. And I would argue that it also improves the readability of your code. So even if for some reason you don't write the best documentation, you still have some good usage examples that can help you in the future or others that may want to use your code. It also like raises your confidence when developing the code, because like sometimes like if you are not, especially if you are not expert, especially if you are changing the code that was written by someone else, like changing things might be scary if you don't have like anything, like if you don't have any test that you can run. Okay, so now I will like explain like various types of tests. I'm sure that some of you know this, but so one of the most like popular tests are unit tests, and they work on isolated units and verify if this particular unit works correctly. And in most cases, you provide the answer, so you know the correct answer, and you are just comparing if the function gives you the output you are expecting. Integration tests are in a way similar, but they often combine individual units in one bigger test. And there are also like regression tests, especially for scientists are like often important, because the nice thing about regression tests is that you don't necessarily have to know the answer, like the true answer. Basically, by regression tests, you are checking that what the result you had like yesterday, you are still able to get this. You still might be wrong, but you are just not changing the output by updating the system. As scientists or like like any like researcher, developers, in a way we all question and test many things in our work. When we're writing a program, we often like execute for a simple example first, and then we try like more complex examples. So basically, like writing tests, it's nothing else than like in a way translating your ideas for verification to programming code, and to make it more automatic. Okay, so testing tools. So since this is PyCon, we'll talk about Python testing framework. So in Python, there's like the unit test that is like more or less the same, there's similar concept as in many different libraries. There's nose test that at some point was like popular, but it's not maintained anymore. That's my understanding. And there is pytest. And I think like if you don't have reason not to use pytest, I would recommend strongly to use pytest, and there's like great blog that explains you the difference. And by the way, pytest can also run tests from unit tests as well. So if you have some tests from unit tests, it doesn't mean that you have to rewrite everything from the scratch. Okay, so the reason why many people are using pytest is that it's very easy to get started. It's actually like pretty complicated, pretty complex software, but it's easy to start. And it's based on like straightforward asset statement. So the code, there's no like boilerplate too much. But the code is like is very readable and very simple. So simple tests are very simple. It has nice, and you will see during the workshop that it has nice reporting and traceback. And it also has nice I'm sorry. It has automatic test discovery. So you can run just pytest, and pytest will find all the tests you have in directory and subdirectories. You can run pytest on like very specific file, or you can also like write test for very run pytest on the very specific test from your file, and we will practice this. So it has also like many useful features, and some of them we'll cover today. Okay, so this we also like we practice this, but just so you know, I might want to use pytest with option -v, just to increase the verbosity. -s, because it's basically if you don't use -s, you don't have like any print statement. You might also want to try sometimes like --pdb, so it basically stops at the failure and to let you debug the code. And of course, like full list of options you can find with -h. Okay, so we wanted to prepare some scientific project, and we were like wondering what we can do, because we had no idea what is your background. We still actually don't know what is your background. And we didn't want to spend too much time on like explaining the things from our domain. So we basically decided like simulation of moving particles in a box. So that's like everyone has some life experience with collision, I guess. And the simple assumptions were like, so all particles have the same size, but can have different masses. Box is like angular, and you have like dimensions. And all collisions are elastic. And particles have different initial location and velocity. So once we defined this, program, I decided to try to write it. And honestly, sometimes this is what I got. There are particles, they are colliding. There is a box. There's like wall, and like balls are hitting walls. And so that's how it looks. And the question is, does it work? I would argue that it works. I mean, it's particles like moving. But the other question is it correct? So I can play once again, and can you tell me if it's correct? How many people think that it's correct? Thank you. Yeah, that's actually a very good answer, like, because you have no idea is it correct, yeah? It looks, I would argue that it looks fine, yeah? It's like, sure, but yeah, I actually had like many versions of the code that looks more or less the same. Yeah. It looks fine. Yeah, so this is basically the problem that we were like working on during this tutorial. And yeah, so I would argue that it might be impossible to write a test that can give the absolute answer, yeah? It's like, what would be the test, yeah? It's like, you know, like many people, like the one test is like, it looks fine, yeah? But it's not like very like trustworthy like answer. It's like actually like, it's not writing a test. So if you wanna do like formal testing, it's very likely that you will not have like one test in mind that you can that can answer you if it's right or not. But we can think about like multiple tests to increase our confidence. So again, like it's not necessarily that tests will give you an answer, is it true or is it right or not, but you can eliminate some bugs and you can just increase your confidence. So so when you think about like this specific example, like basically like there are like three processes. There is like transport, yeah? So these particles are moving because they have some velocities. If one particle meets another particle, there is like collision. If both hits the wall, it's just like changing also like the velocity. So that's pretty much like combination of these three processes. And yeah, so we will start from the easiest phenomena, that is transport, and we will like start testing the transport function. So can you please check if you have did you clone the repository? If you did have problem, please put your sticky note so Anya can help you. So yellow is, I'm done, yeah? Okay, that's good. That's good, thank you so much. And if someone doesn't have GitHub account, Anya can help you just download, and we've fixed the GitHub account during the break. Okay, let me just prepare and make everything bigger. Okay. So as you so I try to provide like all files names, so you are not. So if you are lost what I'm doing, you can always check. So basically, the structure of the code is ignore like the MP4 files, but basically you have like a PyCon test, and you have solutions and you have tests. So basically, in PyCon test you will have like the main code. In test you will have like all codes. Some of them are already written, some of them you will be writing. And in solutions there are all like files that we will be asking you to write. So we provide like some example of the proper like tests. So I will like remind you doing the course. Yeah. Okay. So if you open, I will make this bigger as well. Oh, interesting. I cannot make this bigger. Anyone knows how to make it bigger in Python? It has to be. Where is the settings? You mean here? Okay, yeah. Yeah, I was just trying to zoom like the. I'm using like command. Okay, that's fine. Sorry, I had like so many different versions that it looks like. What is like? Can you help me? When you make a presentation, like everything is harder.
I totally understand. And then I just typed font.
Oh, okay. Okay.
And then I found it somewhere.
It's here?
Yeah,
But you have
override
to
default, not recommended. Let's see, does that help?
Maybe even bigger.
Yeah, a little bigger. Yeah.
Oh, okay. Nice. Maybe bigger even. More.
Now you know.
Okay.
PyCharm.
PyCharm.
Preferences.
Preferences. Okay. Font. Here. Okay. Thank you so much.
You're welcome.
Does it work now? Okay. Thank you. Sorry. I was surprised that actually it doesn't work. Okay, so this is our function. So I will argue that it takes the so log and val might be either like numpy array or like numerics, and we basically like having like location and velocity. We like have like transport the particles doing one step. So basically, we're like adding like velocity times time step. And now, if you go to tests, I perform like some simple tests for you. Like so, the first exercise I actually provided like all tests. So you can either type them or you can like just uncomment this. And I will try to like type this once again and explain. So basically, PyTest does recognize all, like as I told you, they would like automatically find all of your tests as long as your file starts from test and your function also starts from test. So you will see like that kind of like old function is that like test underscore something, yeah? So, and feel free to like type with me or like just and check. So to test the function, we have to provide like all arguments. So in this example, I will provide that the initial place is it like too small?
I'm just wondering what file you're in.
Oh, okay, sorry. Test transport, in tests and test transport.
Can you explain one more time how did PyTest discover functions to run?
Mm-hmm. So, okay. So basically, like it will like automatically find it if the file starts from test and the function start test. So basically, yeah, it's the main reason like why like so. For example, you notice that the directory is called test. It doesn't have to be called like this, but all of the files are starting from test. And all of the function inside should start from test if you want PyTest to discover easily. Okay, so we can provide velocity, and we can provide some time step. And I would argue that the transport is like enough is a function that you actually can think about like the solution, yeah? So basically like what we are taking is the initial location is like 3, and we have velocity 1, and the time step is like 0.5. So, and this is like obviously it's everything in one dimension. So basically would think that the final solution, the final, I would argue that should be like 3 times 0, 5 times 1. And basically, as I mentioned before, like PyTest, it's like one of the reasons why it's like so easy to start is because like it uses like simple. You can use like the simplest assert statement as you can use in other like other programs. So basically, you type assert. You call the function. I already imported this for you. Transport. And you provide arguments. Oh, okay, yeah. And I have to compare it to the answer, yeah. Is this clear for everyone, the structure? Because like we like start from like build like more complicated, so I want to be sure that like everyone is familiar with this. Okay, so we have our like first test, and we can start running PyTest. So, okay, hopefully I'm in good directory, in good version. Maybe not. So I will type pytest, tests, test transport. Voila, it works. So basically like, oh, did I just close it? No, okay. Okay, so this is how it looks if PyTest like run everything and everything is like fine. So it tells you that everything is passing and it's like everything nice and green. But what if I would say that this is like ×2? Now and now you can see how does it look like if the tests are failing. Basically, like it doesn't tell you only that it's failing, but it actually like it would evaluate for you the right hand side and left hand side of the asset statement. So left hand side is like 3.5, and the right hand side is like 3 + 1 is 4. Yeah. So basically, not only gives you the information that it's not running correctly, but it also like gives you the specific like evaluation of like both sides. Okay, so we can fix this, or maybe we can also like we can practice also like using one. I told you that one of my favorite like argument is like -v. So okay, with one test it doesn't look like as good. I mean as useful. But it's basically, it's more verbose, so it will give you the name of the test that is running. So, okay, so once we have this, we can try more. We can try more tests. So this is done. But remember, I told you that my function should work both for numbers, but also for NumPy arrays, yeah? So if I'm saying this, again, you are thinking about the use cases, so it's worth testing. Like, okay, it works for floats, these are floats, but it's very useful to check if it also works for arrays. So the next example is like basically, that's what I'm doing. So you can type with me. Again, I'm starting with test. The name of the function is test transport 2. You know, you can introduce like more meaningful names, but here I will be using the simplest one. So again, it's like here, like instead of like float, I'm providing some array, yeah, NumPy array. And again, a NumPy is already imported for you, and you have like. And the same for the velocity. I will just copy paste this. And our time step will be like 1 this time. And you know, like the answer statement will be very similar, with one difference that I will like talk about. So basically, like let's run tests now and see what happens. I will clear this. Okay. Let's run nice. Okay, so one test, I didn't fix it. So that's, you see, like if everything is failing, it's basically saying like to fade, yeah? And you see that also like, because it's verbose, you have like, you have like specific tests which are like being run. So the one thing is like, because I forgot to fix the first example, the second one, because the second example with array, it is confused because like it doesn't know if it should check one element or like all elements. So basically, in this kind of situation, we have to just provide all at the end. So basically, that would give false if any of the element is not equal. And here I can change this, and now everything should be working. Nice. So that's how it looks like if it's working. It's always nice and green. So are people like typing this PyTest command? Does it work? for everyone? Okay, nice. Because it's like really like, it's tutorial, so I like want you to code together with me. Okay, so you know, like you have very like pretty easy tests, but we can think like obviously like we will not explore all possible tests, but we can think about like one more test, yeah? So this time we are providing arrays, but the time step is like half. It's not integer, it's a float, yeah? So I will just, so it's faster, so I will just uncomment the test transport 3, and I will like run again. And it doesn't work. So it looks, so does anyone can tell me, what do you think it might be wrong in this example? So obviously like 1 plus half is 1.5, 2 plus half is 2.5, 11 minus half is 10.5, and so on. Yeah.
Floating point for arithmetic.
Exactly. So this is kind of like, it's stupid, like just like you might not want to think, because like, you know, like when you write something on like on paper, you have controlling all of the assumption. Here it's kind of like, you know, you have like pretty sophisticated software, like between you and like hardware, yeah. So and there's like many assumptions in the software. So it's actually like, it's not necessarily that you are making like kind of like you know, important mistake in your like in your equations, but sometimes it's just mostly like you are not aware of some of the assumptions that are being made. So in this situation, it's like exactly as it was said, that like because like my initial arrays are like defined only with integers, NumPy will keep this as integers. Like the type of this arrays will be like int. And if I'm adding like half, it basically doesn't change anything. Okay, so, but you know, like you might want to have this situation. So it's like, it's very likely that someone will write you like this. So what can you do with this?
1.0, 2.0.
That's true. You can, but this is like kind of controlling what users will provide. And if you are sure that user will provide with dot, you are fine. But what if like, you know, you are like, someone else will be using this, and sure, you can include this in documentation. Be sure, always put float. But again, are you sure that like everyone will read this or not? Yeah. So I would recommend you to go to transport and basically add some lines that we basically like change the function so all tests are passing. And I will give you like 2 or 3 minutes for this, and yeah, and we'll see a solution for this. So this is like basically like nice, like that's often actually how I write my test. It's like, it's not necessarily I always write test first, but I often like write at the same time. So sometimes like, you know, the basic tests are running, but I'm adding like, I think that I'm adding something like very similar test case, and it stopped running, yeah? So what you can do? Sure, you can remove the test and like pretend that it didn't happen, or you can go to the function and actually change this. So again, this is like in the file, this file. So this is the file with the code. So sensitive. So I see like many people have like yellow. Is it updated or? Okay, still some yellow. That's good. No pink. That's good. And like if your person next to you has yellow and you are struggling, I think like they would be like very happy to help you. So yeah.
So if I were an awful person and
Yes.
I wanted to skip the test,
Yes.
how would I do that?
Yeah. So actually,
Okay, sorry.
yeah. So PyTest can offer this because sometimes, like, what happens sometimes is like, okay, I know it's failing, but like really now I don't have time to work on this. So, like again, like obviously, if I have some deadline and I know that it doesn't affect my result that I want to produce like today, I might not spend 2 hours to fix this bug if it's like something. But like if I remove tests, will I remember this? Not really, yeah. So there's a way. I also like have more examples for this, but since you asked, I can like introduce a way. So there is like PyTest offers also these Excel decorators that you can mark this mark PyTest, sorry, typo, as X file.
Or skip.
Yeah, so this is like skip is if you don't want to run it at all. And X file is kind of like it will run, but it will like not report this as a failure. So you will still have green color, and I will show you how does it look like.
It will be a failure if the test passes, if it's
No,
X failure.
it's not. X pass. You can bring X pass. Okay, so reason like, and you can like it. I think now it actually forces you to write a reason. So doesn't work for arrays with t-type int. Okay. Where is my terminal? Somewhere. Okay. Let's see what happens now. You see? So it's actually like saying that it's still green. It's still reminding you. So every single time you run this files, it will tell you, yes, you still have this one test that is failing, So you can ignore, but it's kind of like, it's harder. So at sooner or later, you might want to actually, like fix this. Or someone else will ask you like, oh, wait, like, great that you have so many tests, but I noticed that some of them are failing, yeah? So it's like, maybe you can do something with this. And you can say, yes, you can do it as well. So, you can. And if the test, sorry, too many windows. So if the test is passing, so if this test is like actually working, you will have situation that it's XPath. So it's actually telling you that actually, by the way, you already fixed this, so. Okay, I will remove this. Okay, so I think like, because we don't have too much time before coffee, we, there like, obviously like there are many ways of like fixing this. One way I did, it was like basically, so whatever like I have, instead like, you might check if it's int or not, but I'm just like, is it n-type? S-type, sorry. S-type, type, float, and I would just ask him to not copy. Instead of we have like, actually, well, yeah? And I will do the same for the second array. Actually, the log is more important. So, okay. So that would be my fix. You could have like different ways. Where's my terminal? Here. Okay, so let's see what happens. D-type. Okay, so I made mistake. It's like this, yeah? Let's see if it's working now. Yeah, it's working now. So now when I see like it's XPathing, it's the perfect moment to remove the X file. And now everything is working, and I don't have any tests that are waiting for me to be fixed. Nice. So I would just try like, let's see what is the time. I don't see the, oh, here is like, okay, so maybe I will ask you to like try this. Maybe this way you can go, like if we have like more time, we can come back to this. Because like, so again, like, I told you that you kind of like think about the output, about the use cases, yeah? So in this situation, for example, like many people would, instead of like array, would give you a list, yeah? So what would happen if you provide the list to my function? Would it work? Yeah, it's very often that it will not work. So we can test it. No, it's not working because basically you are multiplying list by float, yeah? And even if it's int, it will not raise error here, but obviously it will not do what you are expecting. So again, like if you think like, you can like basically have like two choices. Like you can provide some extra code that you are changing the list to array, and once you have array, you know what to do. Or the other option is that maybe you want to raise exception if someone is providing list. Maybe you don't want people to provide list for whatever reasons, yeah? So you basically have two choices. But for example, like assuming, especially if you are like writing the code that someone else might be using, if you are assuming that it will never happen, you might be surprised actually like pretty quickly that someone will provide a list instead of array. Sure, if this is like pipeline somewhere that you are absolutely sure that you have everything array, maybe you can skip it, yeah? But it's actually like, up to you. It might be like you are like ignoring this up to the moment that someone will complain you that it's not working, yeah? So again, it's kind of like makes you think about use cases, about like what kind of input you want to allow people to use, and you're kind of making decision what to do with this. Okay, so that was like transport we're fixing. Now it should be like working. If it doesn't work, if you see like you are struggling, you can go to solutions and basically copy the file from solution. But it's the mistake that was in the transport wasn't so important, so it will not affect the tutorial. So you don't have to do it if you don't want to. Okay, so we have like these are solutions. Here, like you can read about skip and exfile more. And okay, so now like a bit more interesting like process. So again, like you have transport, but you have like collisions, yeah? So because we're like elastic collision, and this is like basically taken from Wikipedia, I don't know where, is it still like, I thought that I had like one. Okay. I used to have some figure. I wonder what happens. Okay. Basically, when you have like elastic collision, for those who don't remember like physics, it's basically like the total momentum has to be conserved and total kinetic energy has to be conserved. So basically, like when you start from these two equations, you can derive equation for the final velocities, having the initial velocities, yeah? So in this example, like U1 U2 are like the velocities of the initial velocities of the particles, and V1 and V2 are like the final ones. And okay, I already like provided you, the function. For you, it's in the elastic collision. But now I wanna ask you to think about what kind of test you might wanna write for this specific example, and you can think what kind of answer you can have, like what is like kind of like easy solution that you can think right away that you can use for your testing function. And I would encourage you just to talk to your neighbors and think for a moment like what kind of tests, without even writing them. E, 15 było. Chyba. Mhm. Yeah. 12:40. 12:20, tak. Mhm.
So already she's got it. She's raising it. Yeah, the two particles will be exactly the same. Yeah, so you would create a test where you have the particles.
Aniu, możesz podejść?
Then these are supposed to be. Well, I do.
So the dot was question, what does the dot function do in NumPy? It's basically does the scalar multiplication.
Oh, okay.
Yeah, sorry. Like,
Well, then so these have to be.
you don't have to analyze too much the code. You can also just think about like kind of, because like, it's actually like, I also like do it like this way, but sometimes it's actually like, it's useful to think about tests without seeing the code, because
I think it would be useful if we knew the subject matter better. I would be able to do
Yeah.
that. But since this is like completely off topic for me,
yeah, sorry,
I
like,
logically tell you what the test should be.
Yeah, so that's why, or like, yeah, definitely we talk about this. Like, I understand that was like kind of the biggest problem because like you have like so many different domains. So we try to use something that some people might be familiar, but obviously we'll be talking about it. But basically, if like coming back to my comment that it's sometimes, you know, if you read the code and build a test based on this, obviously if you are like person who is writing the code, it's hard to not forget what is in the code, yeah? But in general, generally speaking, it's sometimes useful, like kind of like, okay, what do I expect this function to do without like checking the code? Because when you really like can be like, you can have like fresh mind and see if this is actually doing what it should do or not, if this is actually doing what I wrote in the function. It's still like it's useful because even if I claim something in the function, it might be wrong. But it's often like useful to think what you think it should be doing. Okay, so my apology for those who it's kind of not familiar, and as I said, it's kind of like hard to prepare like example for everyone. So I would argue like just going through this equation. So one of the very simple case is if masses are the same, basically V1 is U2 and V2 is U1. So basically we're exchanging the velocity. So this is like one of the example. Oh, what are the, like, that you can think that is kind of easy? What are the other examples that people could think about? What kind of other tests you can think about? Yeah?
Input test, like checking for negative mass or something like that, illegal value.
Yeah. I would be surprised if it's working, yeah. I don't remember writing this, okay. Yeah.
Like infinite mass on one of them.
Yeah, it also doesn't have this, yeah. Nice. I mean, but infinite mass, you can think, actually, yeah, depending how you want to treat this, yeah, because sometimes you can think like about the wall, that it will not move, kind of, but yeah. What else?
You could check the momentum and energy.
Yeah, perfect. So, you know, even if you don't calculate the velocity, we started from assumption that energy and momentum is conserved. And we can check if this is actually true at the end. Yeah, so anything else? But I really like the idea that we actually like, you can check the input and output. So it's very useful. So input, as in the previous examples, like you want to think about what kind of input your user might provide, yeah? And it's better to catch it here because like, you know, obviously these are like very simple functions and it's easy to fix, but also like, you know, sometimes you're like, if I now calculate something with like negative mass and we go somewhere further, yeah, you might just realize like much later in your pipeline. And if you catch it here, you know it's here. So yeah, so it's like, so you have still like 5 minutes to write some of these examples. So you can write on your own. I can also like start typing, so you can follow me. You can write your own examples. So I will follow with the first idea that I provided, that if the masses are equal, they should exchange the velocities. And if you see the code, you can also see that the 1D is actually like very like default arguments. That means that I don't have to provide M1 and M2. And if it's not provided, it will just take 1. So this is like the simplest case. Masses are 1 and like obviously are equal. So, okay, so let's see. So we already called the function. We have like our final solution, final velocities. And now we are like, want to have some asset statement, yeah? So asset, as I said, it would be this. And no, -2. So we're like exchanging the velocities, and hopefully this will work. So now the particles, the second particles, we have like 1, and the first particle we have like -2. And let's see if it works. So now I will be testing different function, 1D. And it works. Nice. Yeah. Okay, so it's actually like very good. It's actually a very good point. So PyTest stops whenever it has asset error. So if I make mistakes here, it will just stops here. It doesn't mean that the next asset is right. It's actually like it just stops at the very first one. That's why, for example, like it's good to not write too big tests that they have like 20 asserts, because like then it's like actually like it will stop at the first one. I mean, it's still fine. It will still tell you that it's failing. But for example, it sometimes makes more. It's more useful to have like more tests, and you see, okay, this kind of tests are failing. I have like answers for multiple asserts, and if you put all asserts to one function, you have like answer from one assert at a time if it's failing. So yeah, but it's a good question. Thank you. Okay, so yeah, we can check. You can also like check, for example, like for me, it's like, okay, is it like it works for this, but I wonder if it's work if it's actually, you know, masses are provided, yeah. Again, it sounds like pretty simple, but I mean, like many places that you can make like silly mistakes. Okay, it works. And I really like the idea that like checking the energy and the momentum. But one of the tests that I also had, it was actually like someone actually said that if the mass is infinite. But one of the examples that I want to have like was, and this is all in solutions you can see it. Okay, what? What do you think will happen if the first mass is 1 and the second mass is like 10 to 7? Do you think that the mass second will change the velocity? Probably not. It's big. So we can start like from checking this if it's actually like if it's true. If like so, second mass has like -2 at the beginning. So let's see if it has like -2 at the end. And that's what you get, yeah? It's actually, I was right that it's pretty close. It doesn't change really mass, because if something is like very big and it's like collide with something that is small, it will almost not notice. But it will change something, yeah? So, and you will have like many situations like this, that the results are close. You can say that it's close, but it's hard to expect that it will be like exactly the same, yeah? And for this, you have like many various way of doing this, but one of the I want to introduce is like pytest. What was asset equal? How was it? Approx. So you can also like NumPy also like provide some nice tools, but pytest also like is actually ready to handle this for you. And of course, like you can define what does it mean approx. On my slides. So these are like again the files, and you can read more about pytest approx, and you can set the error that you are ready to accept. Okay, so and as I said, I really like the example with energy and momentum, and these are the examples. If you go to solutions, you will have like examples also that explain that compare the energy and momentum. Okay, so now we have like 10:13. So the coffee break is like in 2 minutes, and I was told that the snacks go quickly. So, so as you want. So if anyone is having like any issues like with like setup environment, like, you can let us know like during break. If not, we'll see you in 20 minutes. Yeah.
signal, and it's set over here. Now the moment of truth. Now that we're playing with fire.
I wasn't so brave.
There you go. All right.
not in charge of mic, so first I have to shout.
You can put a sticker here, no?
Yeah, stickers, yeah. Okay. I actually did find my figures. It was actually there. I don't know if it helps, but basically, like when you think also like maybe when we think about like 2D, you actually also can decompose like 2D collision to 1D collisions, and the one that is exchanging, kind of changing the velocity is along the normal one. And I don't want to go to details because I do know that like it's not like, for some of you might be like obvious, so for some of you, it's not so interesting. Just saying that actually like 2D, it's actually like when you see how I wrote my function of 2D, I'm using also like 1D. So we were testing 1D collisions, and what I would do if I test the code, like I would also think, okay, 1D is working, let's see it's actually like 2D is working. So again, like it's not as easy to calculate in memory what would be like the velocity after like 2D collision, especially because like the balls might not like collide like centrally. So the math is slightly more complicated. So, but what kind of like simple example you can think of that you are like you would be able to write a test right away? Anyone?
One of them is stationary at the beginning.
Yeah. What else? You had coffee. So, I need some proof that it's working.
Conservation of momentum.
Perfect, yeah. I also I would think like the other one that I had in mind, it was like, okay, it's 2D, but actually if you provide only like velocity in one direction, it's 1D again, yeah? So so I will just show the test because we don't have enough time to write everything, but you can write this later. But that's basically my examples, yeah? So here the first, the velocity should be like 2D, but one component might be 0. And you can do the same in the y dimensions. You can think like, okay, it doesn't check like everything, and you are completely right. It doesn't check like everything, but it does test something. And again, like you can just simply like test the energy and momentum because you know that that has to be conserved, whatever is the velocity and location at the beginning. Okay, so that's how I would approach. So you always want to think about like, okay, this is my big code, even though in this situation majorly it's not so big. It's like how can I find like pieces that I'm able to test? And it's like, don't worry if you don't know the answer, like if you cannot like write a test that will cover like everything, yeah? You want to cover as much as you can. And maybe later someone else will cover more, like it's fine. It's like, but I mean, you probably don't know how many like mistakes we notice after when writing this test because we didn't think about something, or even like I just made like silly mistakes because like somewhere like instead of like scalar I was using vector, and the way how NumPy was treating this, it was like I'm fine with this, but I was like doing the math that I was not planning to do, and for a simple example it was working, but for more complicated it didn't. But like the balls were colliding, like it looked more or less fine, yeah. So so it's worth testing even if it looks simple to you at the beginning. Okay, so I did say that you have like transport, you have collision, and you have hitting the wall. You can also like write some function and test for this. We will not do it now. But let's test the simulation. So now I want you to test the entire simulation. And now obviously I do not expect you that you will provide me the final position of all balls at the end of the simulation. Yes, it's like, it might be hard, but let's see what we can do about this. So that would be like more like integration tests. So the one that I was showing before was like more like unit tests, and now you can think like about integration tests. You know, obviously like there's no like strict border between one and the other. So let's go to, you have like a test in test simulation. I started writing this, and we'll continue. Where is it? Okay. Oh, no, that's solution. No. Okay. So we have a simple test that, again, I have to define my domain. I'm defining Tmax because, remember, this is like now simulation. So what you want to have, like, it's time step and the entire like time length. You want to have a radius. You want to have like initial positions, and you want to provide mass. And then you can run like simulation. We will not go through the function, but it is in the code. You can check this later. The second part, like the movie, is like exactly what it says. It will, on top of testing, you will create a movie that you can later, if you have, that's the reason why we ask you to install this Apex. Thank you. Yes. If you don't have it, it might still work with HTML. So I have in the code that I know that I was testing on some Linux distribution that without even FmpEg, it will create HTML. It would not create MP4. So this is also in the code. So it might produce MP4 or HTML or nothing if you don't have anything. Okay. So yeah. So what about like we run this test? So again, I'm going to my terminal, and I will be running test simulation. Okay, nice. So I can check if it created. So I know that I have all the software I needed. So it did create. You can check as well if it's creating for you or not. We can even see the, oh gosh. PyCon alt, yeah, I have like everything here. Yeah. And if you have software, it should look like, you know, like this. So it's the bouncing and then coming back. The simulation is not enough long that you can change always so it actually collide. Okay, but you see that like actually like the time step was pretty long. And we also like one of the things that you might wonder if the function actually works for different time steps, because like many of the function does depend on the time step. We did a test collision, so collision depend on velocity and masses, but actually when we run simulation, we introduce one more, like actually two more like parameters. It's time step and total time. So actually we might check different time steps. And if we go to our test, you know, you can write like as many tests as you want. You can copy paste and run with different time step. But actually one of the things that is nice with PyTest that you can do it more like automatically. So for this, I will introduce a new decorator. It's PyTest again. Is it Mark? Yeah, Mark. I will not try to not make typo. Yes, I think that's the spelling. Okay, so you can type with me. It's PyTest Mark parameterize. And now you are like, you have to specify what you want to parameterize. So in our simulation, it will be dt, so the time step, the length of time step, and let's try like multiple ones. So we had like 0.5, so we can have here, but we can also have like 0.1. So now we just have to remove this one because otherwise it will just always override. So this is important, remove this line. And the syntax for this PyTest mark parameterize, you are providing whatever you specify here, you are providing here, as well as a function argument. And here is the list, so you can provide as many values as you want. Also, you can provide multiple arguments. For now, we will be testing the simplest one, so just different time steps. Okay, so let's see how does it work now. And you see right away that it's actually first of all, it ran like twice. Second, you can see that now, if you are running with -v, I will put this higher, sorry. In addition to the name of the function, the name of the testing function, you have also the value of dt. So you can see which one is not working. 0.11, did I say it? Oh, okay. I actually did write for exactly the same, okay. That may be not as useful. Now it's better, okay. So it's actually, but it's actually like, yeah, it did recognize that it's the same and it just ran twice, yeah? That's actually, I didn't know that that's what it's doing. Okay, so that's how you said, so it's very useful whenever you wanna, obviously you often just don't wanna like copy paste the same code, but it's useful to write it's useful to test different values. And to see this, for example, like, you know, let's see what happens if I add one more, and it will be 1, dt equal 1, and see what happens now. And it actually doesn't work. And as you can see, I actually was prepared for this. So because I had this error before, I wrote a test saying that if you have like, basically my code is assuming that like, you know, like the particles are not at the same place. And if we sometimes take like too long time step, it might happen that they are exactly in the same place. So my code will not work for this. Sure, I can change my code, or I can just write an exception that is like, you know, two particles are exactly in the same place, consider using smaller time step, yeah? It's perfectly fine. So, so that's actually like, so obviously we want to remove this, this value from here, but there's one more thing that you wanna do, because like, as you see, like, this is my exception. This like, I did specifically ask to raise this exception. So one thing that you also can do with PyTest, you can actually test if you are like raising this exception. So, and that also might be very like useful. So we can write the second test. And just to be faster, I will copy paste the beginning of the test. Okay. So change the name. I will introduce dt again with 1. And let's see, is it still like failing? Here, for example, like we can show like, I want to run, let's say, only this function, sorry. Okay, it's failing. So what we can do? Like, again, like, one thing that we had like before, I introduced xfail, yeah? But it's like, it's actually not what you want to have. It's because xfail either will give you xfail or xpass. It will not raise an error once it's passing. So PyTest actually has like specific like syntax for checking if the error is raised. So it's like with with PyTest, rise exception. Is it rise or rises? Rises, okay. Exception. And now PyTest will expect this to, I can show you once again here. With PyTest rises exception, and again, you have also this in solutions, so you can also check this in the solutions. Let's see what happens now. So now it's passing, yeah? It's fine. And I can also show you what happens if it doesn't have this. Let's say I will just comment for a moment this. And then once again, it will come, oh, okay. Okay. It will complain. Did not rise, yeah? So it also like give you a full message what is wrong, so it's pretty useful. Okay, let's come back to my original one. Okay. So let's double check if all tests are running. Okay, great. So that was pretty cool. You also like should have, if the movies are working for you, you also like should have like already like the second movie that has like different time step. I mean, I think the simulation should be longer because we cannot see that it's like, you can just change the Tmax. Okay, that's one of the cool things that I think is very useful. Without PyTest, it would be much harder. PyTest like gives you like, it's a tool that makes this like very, very easy. Sure, you can always run your own function, write some loops, etc. But also like remember like the difference also between loops, because you can also run a test that has loop with these parameters. But it was already a question, what happens if you have multiple assets? So this would be exactly the situation when you have multiple assets. And the first one is a phase, it's just phase. Here you have like actually it's running everything. It gives you like the full report, and it actually gives you like very specific information which one is not working. Yeah, so that's why it's also nice. The other cool feature I want to introduce is PyTest has fixtures, and you can like, I also like try to make a link so you can read more like later. Okay, so it's often the case. So like here, we are running some simulation and we are like checking output. But like here, like the simulation are not very long. Yeah, we can like run as many times as we want. Sure, if we wanna like increase Tmax, because actually like, what you can expect, like if you increase Tmax, can you be sure that all tests will be passing? And if yes, why? And if no, why? All the tests that we've been writing. What about the energy? It's like, sure, we know that it's the physical law, it's conserved, but depending on the math, like sooner or later you might have some small differences, yeah, because like it's not perfect, yeah. So, and it depends, like I was using float 32, it will be different with different floats, etc. So it actually perfectly makes sense to run some of this longer simulation to see if it's still conserved. And maybe you will have to change slightly the test again to not compare exact numbers, but maybe if it's close enough, you know. So obviously, if you are like losing energy after every single time step for 10%, something is wrong. But you might expect at some point that some of the values are not conserved. Okay, so basically sometimes the simulation might take long, might be very expensive, and you don't want to run this like for every single test, yeah? It just doesn't make sense. Sure, you can save some output and do it like manually. You can do it, but if you are using PyTest, actually PyTest can do it for you. So, and this is pretty cool. So I opened just the file that has test simulation fixture. And I will just like go through this like without like writing anything. So basically, like here you have example how to write fixture. You can specify the scope. It can be function scope, it can be module scope, and it can be one more. I forgot, sorry. You can check this, yeah. So it's often like useful for module if you don't wanna, if you wanna use the same function, if this, the same data that you generate here for every single test. You also like, you can add function to cleanup. For data might be important, might be not, but for many different like things, it might be important like just to close some connections, for example, yeah. And yeah, and you see here, so you will have two tests. So PyTest will find two tests, test energy and test momentum. But here we are like requesting the data. Yeah, so that's basically the syntax that you are creating this, and you can request this later. And let's see what happens. So this time we'll be using the option -s. I told you that it might be useful. So, sorry. Okay, so what we see here. So in the test file, you can see that we have like a couple print statements. So we have print statement for creating data, we have print statement for removing data, and we have like print statements when we are running the functions. And you can see that PyTest recognized that you will be using this data for like two tests. It created at the beginning. It ran the first test, test energy. It was passing. It ran the second test, test momentum. It was passing, and only then removed the data. So this is actually like pretty cool feature. As I said, like here, maybe you will not. Obviously, we prepared examples that are like that you are able to run rather quickly. But this is actually like pretty cool features if you have to provide something more complex and you don't want to run the same things over and over, yeah? And you can provide multiple features, and PyTest will figure out the best way to actually like create and close it, yeah? So you don't have to think about this at all, so, yeah.
Just curious, why does the data function has a request argument?
That's the PyTest syntax. Yeah. So it's kind of like you are able to request, like, yeah, that's the just syntax. Other questions? Okay, so let's go with my presentation. So okay, so now we will we move to Anya and to continuous integration, and maybe just because we need some time to change laptops, etc. So first of all, like, do you have any questions on this part? I mean, you can ask later, but it's also like good time to ask. Yeah.
This seems like a very impactful topic. If we really wanted to dig into this beyond the documentation, what's a good resource to do that, particularly with fixtures?
We provided some of the resources. So, for example, like at the very beginning, I also provided. I like this guy. Where is it?
It's just at the end, no?
Yeah. But this is like to the blog. Oh, here. So I like this blog, and actually like fixtures are very well explained here, I believe. And this person also like published a book. But there's like many things that is actually covered in this blog. You can you read it for free, and it's actually like fixture. It's the place where I've learned and I understood finally. So yeah, I recommend this, and you will find references in the slides. Yeah, fixtures are really like powerful, and you know we only cover like small piece of it. Let me go to. There's too many things to finish on my laptop. Okay, let's close this. Okay, so now maybe like when we are like changing, I want to ask you like second question. Continuous. Continuous. And you again have option never heard. Okay, so you can put your name and some explanation that you know what is your experience. And now we move to Anya. Oh, okay. Right.
Okay, so before we move to the CI thing, we still have 2 example tests for you to prepare. And in the meantime, you can fill out whether you're a CI expert or not. So the first test, as Dorota described, is the regression test. And very often you might spend some time on unit tests, but at least from my experience, the regression tests are usually the first ones, and unfortunately very often the only ones I write, at least initially. And it's, first of all, in the absence of truth, you can always test if the result is the same as it was yesterday. But it also helps, not in scientific computing in general, but more like in confidence building, right? If you have, I don't know, 2 postdocs that you want to start contributing to your project, or maybe, you know, your friends, then you would like to be able to accept their pull requests or their changes quickly so that you don't disencourage them, but also efficiently so that you don't destroy everything you have been working on the last 4 years. So then having a quick report saying, you know, I'm not sure if those changes are reasonable, but at least your code works exactly the same as it was working on Monday, is a very useful feature to have in your workflow. So for this simple example we have here, there is a draft in the tests folder for the test regression where there are some simple functions already provided for you on like how save data to some folder and how to open it. And I encourage you to open this draft and think of some input condition you want to use for this 2D simulation. You know, save the data and then basically create your regression test. So then have an assert that reruns the same simulation again with the same input and see if the results are the same. I will give you 5 minutes, I guess, to copy it, and then we'll just go through the solution. But it's also pretty useful if you're testing on different machines, because it might not be your postdoc that's breaking your code, but maybe the Linux versus Mac or some other package version issues. So again, having a test that tests, is my energy conserved the same as it was yesterday, or are the locations of my particles exactly the same as they were yesterday, is very helpful for you to sleep peacefully at night. Okay.
At some point,
Microphone.
Does it work? Yeah, okay. So at some point I was the only person when we used to work in the same group, and I was at some point the only person with OSX. And it was like quite often when they asked me to do anything, like was like, yeah, but it's not working. Because it's really like, it's hard to expect that every single system we have exactly the same answer, especially if you are using like complex algorithms. Sure, if you are like adding two numbers, probably it will be everywhere the same. But if you are using more complex functions, you should expect that it might be slightly different. And if you are ready to accept the difference, you are fine. If you are not ready, then you should think.
I mean, you can also just take whatever test you wrote already and just turn it into a regression test. I don't necessarily. Better?
How do you guys account for the differences in systems? Like you were describing Mac OS X, you were having issues with it compared to other systems. What's your guys' technique for dealing with that?
So we'll come back to it with the CI platform. I mean, it helps if you have different people having different systems in your group. So that's a first level of defense. That was Dorota's case in our group. It also helps to just run it for different Python versions, different machines.
But if it's like, if you are asking what we do once we notice that there is difference, I think it's also like, as I said, is it the difference small enough that you are just accepting this? You're just like noticing, okay, this is like slightly different, but this makes sense. But obviously, if the differences are too big, then you have again, you can ignore the fact and pretend that it didn't happen, or actually have to explore, okay, what is the difference, and actually which one is correct. Because it can happen that, for example, from time to time, even some C libraries that have been using for years, they find some bug, yeah, and in newer version might be different than in the older versions, and it can happen, yeah. So then you have to if you observe this and you explore this, sooner or later you will notice, oh, okay, I have two different versions of this library, and you might find something on website that, okay, we fix this bug, and then you know what is the answer, yeah? And you also know that it doesn't work with older version, and you can share this with others, yeah, so.
So I can ask you if you're done with the regression test. Can you put the yellow sticker? Or if you're done in general, you can also just put the yellow sticker on. I see some yellow stickers. I'll just slowly walk through what I wrote for the regression test. It's exactly the file you have in the solutions. So again, like I have to create first my reference simulation that I will later treat as the solid truth or the only truth that I have. So it's some initial parameters to the same simulation we've been using before. I already saved the data, but in case you want to save it in a better way than just copying from your terminal and pasting it into some text file, then that's one way to do it. Then I'm reading my reference simulation from the file I've created. And Dorota was showing some way of testing the asserts. That's my favorite way of doing it, so it's from the NumPy testing package. And again, you can provide the absolute and reference and relative tolerance to how close you want to be to your reference simulation. And if you're testing it on different machines, don't be surprised if those tolerances will be different between Mac and Linux or your laptop and your friend's laptop. So it's very often the case that you create your test files here, then let's say you push them to Travis, which we'll do in a minute, and then the Travis tests fail. And the only reason is that your tolerance is a little bit too tight. So then you have to ask yourself this question: is it still okay if the epsilon is 10 to minus 7 and not 10 to minus 8? And I don't have a good answer for that. So it's kind of your understanding of what you're testing and how the simulation is behaving. So that's this regression test, and I hope it's big enough. So don't mind the way. It's not, I mean, I'm not doing anything. Right? No. No. All right. You just have to blink in the correct frequency. So yeah, just run the test. Test regression final. And you think? Okay. No. Could be. Yeah. Thank you. So let's see. Is this still okay? Yeah. This one. All right. No. Okay. We've got this. All right. So then, just to show that, maybe if I'm a bit too optimistic with my tolerance for my tests, so I'm testing the relative tolerance of how close my current simulation has to be to my previously saved reference simulation. And I run the test again. Oh, it's still okay. No? All right. Yeah. Oh, okay. Maybe later I will figure out. It should, at some point, you should reach the tolerance, and I'm pretty sure. Yeah. Anyway, at some point it should fail, but so that's the regression test. And another test I wanted to show, but I will show it like really very, very quickly, because there is actually a tutorial that will do a much, much better job at talking about it. So it's a hypothesis package. And it's a hypothesis package basically allows you to stop hard coding your input conditions to your tests. And instead what it does is you say, for example, my mass of my particles should be changing somewhere between, maybe not 0, but like 10 to whatever, minus 3 and 10 to the power 3. So you provide to hypothesis the expected range of the values that are changing. And then you ask it to run your tests multiple times for different configurations of those initial values. So it's very often the case that your hand-picked initial condition will work, but some other random combination of values might possibly not work. So it's a very cool way to have even more tests in your test. So the tutorial for this is actually here in the afternoon, so maybe some of you are even sign up for that. And if not, I'll just give you a very small flavor of how hypothesis works. So there's another test in the drafts that's called test hypothesis. And here I show you the minimal syntax, the minimal hypothesis syntax you need to have to get it running. So that's like all the imports you need. And then once you get rid of the skip, and then you can just say, again, using a decorator, you can say what is the expected range of values for my first mass of colliding particles and my second mass of colliding particles, and then write or convert whatever of your 1 or 2D tests that you had, so that now it runs for those different configurations of masses. And again, I'm going to give you some time to do it. And there's already an answer ready for you in the solutions file. And after 5 minutes, we'll run the test and see the result.
So you can put the yellow thickness now down and put them again once you're ready.
Ten test.
Jakiś on powinien fail?
No, w pewnym momencie tak.
Ale to nie ponad twoim laptopie cały czas jakby?
No tak, ale jak jest tu minus 30, to nie powinno działać.
Ale montujesz może przypadkiem, tak? Nie. Zaraz zobaczę. Ale nie opisuję.
So it's a little bit better. I just decreased the zoom. It's a little bit better.
Well, it probably is a sync issue. Like, again, the resolution isn't exactly what it wants. So
Okay.
what we're going to do, though, I'll keep an eye on it. Obviously, we can sort of balance out, but we're going to find a different port.
Okay, no, I think it's not so bad as it was before.
We'll find a different port as a backup. If it
Okay.
starts going really bad,
Okay,
we'll
okay.
just swap.
Mi bardzo szybko.
No właśnie.
Na swoje żywele to po prostu mamy to już jeden system. Możesz pokazać
Mhm.
ich, nie chcesz, żeby one po prostu
To chcesz się na chwilę podłączyć?
to znaczy, no to ty powiesz, nie? To możesz.
To co, podłączyć ciebie na chwilę?
To skąd możesz coś te hypotezy założyć?
No. Najwyżej na koniec. That's a very good question. I don't know. That's probably an answer on the tutorial or in the documentation. Do you know if it's deterministic?
Like, I haven't done it like too much with hypothesis, but I only remember that once it fails, it saves the examples that it's failing. So the next time we run this, so the one that is failing is like, otherwise like it's actually better that way, like actually like it's, yeah.
Yeah.
But the one that is failing is actually like, we'll keep saving this.
That's what it does. That's all you really need, right?
Unless you fail too often, right? So again, if you're done with this test or done in general, then put the yellow stickers. And if you need help or you want to talk with Dorota, then put the pink sticker. Okay, so I just, again, copied from the solutions, but any test that you had, yep.
Yeah, I'm just curious, how can we make use of the print statement?
Ah, no, yeah. The print is only for now so that I can show you for how many different masses the test is run. No, I'm just like, my test is the asserts here at the end. So for each mass first and second mass that are chosen for me by hypothesis, at the end of my test, I test that my kinetic energy is conserved in my simulation. So that's my test. And the print statement is just for us to see how things are in the simulation. You can have sometimes print statements that are shown to you if your asserts are failing, which could be nice for debugging, like not only the error message from the assert itself, but also some further comments.
But I'm guessing that, are you asking that why you cannot see it?
Well, no, I know I can't see it. I'm just wondering how I can take advantage of print statements as I'm developing my test.
-S, so are you?
Oh, yeah. Sorry. So that's basically the changes. The only changes you have to make to any of your tests is have this decorator on top, pass those two masses into your test function, and then pass them on into the simulation setup, and then calculate your energies and check if they are still the same. And if I run it, so I ran it for some different reasons. I have different Pythons on my laptop, so I have to kind of force PyTest to use Python 3. If you don't have problems like me, just ignore it. And then I use the -S to ask PyTest to show all the print statements on my terminal, and my -V again for making them more verbose. And then if I run it, you can see all the, or you don't, you can see all the different mass configurations and the end result kinetic energies that the test has been run for. Yep, so that's the one and only test for hypothesis, yeah?
At which point do you specify how many tokens or cycles you want to run?
I did not, so that's, I'm guessing, the default number. I'm pretty sure you can, but again, there is probably a very good tutorial in the afternoon about exactly hypothesis, so I didn't dare to have any more information because there is a smartened person somewhere here that knows. All right.
You can wait for it.
Yeah, find him and ask him or her. All right, so that was the hypothesis. the solutions we have in the solution. So that's pretty much it from the simple test, regression test, hypothesis writing. And I mean, if you're doing that, that's already awesome, and you're much more confident in your results. But your confidence level kind of still depends on how often do you actually run your tests. So you might be a very honest person and run them every time you change anything, but from my experience, if things are not automated, then they tend not to be run all that often. So another, like having tests is one level, and then having the tests done for you automatically, it's the next level of how you can improve your workflow. So basically you don't have to consciously decide whether or not you're running the tests. You always run the tests, or someone else does it for you. You get immediate feedback. That immediate feedback can be done by email or maybe through Slack or some other ways of how you communicate with the outside world. It can be very easily integrated with your workflow, and it can help you to test on many different machines or on many different package distributions if you happen to have to do it. And again, I'm pretty sure some of you could write some bash script that would do that, but you don't have to. There are integration services provided for you. The two most popular are Travis CI and Circle CI, and they both can be very easily integrated with your GitHub account. So I will, in the next slides, I will try, if you already have GitHub and Travis, then obviously you're the expert. And if not, then we'll try in the next part of the tutorial have it configured so that the tests that we have created are automatically running for you. But the basic workflow would be that you code whatever things you're coding, you push your code to GitHub, and then somewhere in the background on Amazon Cloud, some computer is being given to you for, I think, 45 minutes if it's Travis. And during that time, you can run as many tests and test as many things as you possibly want. So let's see how it works. I'm assuming you already have a GitHub account, and I'm assuming you have forked the tests tutorial that we are using to your GitHub account. If you have not done this, then please start by doing this. And then the next step is, if you don't have a Travis account, then create one by going to this webpage and signing up with your GitHub account. And if those three things worked for you, then please put the yellow sticker on. And if you need help, then please put the pink sticker on, and we'll try to salvage this. Oh yeah, I should have mentioned GitLab CI. That's another option, yes. Yes.
Does it matter where in our repository structure we put the YAML file?
I usually put it at the top. I think if you want it to be done automatically, that's the place. But I didn't test in other, so. So that's how it looks for me, because I already have an account and I have a bunch of repositories that are tested by Travis. So yeah, if you are a Travis expert, that's what you're going to see. If you're not and you're just opening your account, then what you should see is that Travis will be asking you what repositories you want to add.
So yeah, basically like here, on the left part, you might not have anything, but there's a plus. Can you point to the plus?
Mhm.
And here you can add the repository you wanna.
Well, it might have happened to you automatically when you first sign in with your GitHub account. In case it did not, then the plus should save you. And for this one, I would really like to see all the yellow stickers. So I will wait a little bit more, and then if you still don't have a yellow sticker, you will probably get Dorota coming to you anyway.
You leave this room with Travis.
Yeah, I think like the tests are nice, but this is also a life-changing event for you in case you did not have Travis before. So yeah.
So.
Mm.
Will you explain how to turn on the specific repository?
Well, you can add the repository.
Yeah, but now you have to like change the setting. Yeah, exactly. So you figure this out. Just kind of keep.
Yeah. I think there's one more over there.
Because you haven't run any Travis job, you don't expect any jobs to be run.
Just want to make sure I'm doing it correctly. So after I push back, having this, do I go to Travis too? Like there's a there's a tab where it allows me to
So if you
turn
go
it on.
dashboard here, I think
Trigger build.
this should be one way to do it. It will also work. I'll show you how to make it
Okay.
work from the website, but this should, in principle.
Oops, so it's not this. It's this. So that's kind of triggered its general report now, or is it?
No, let's see if it works the way we planned it in the
Okay,
repository, and then.
Did you already ask to create a Travis file?
No, not yet.
Okay, not yet, so we're fine.
Do we move the Travis code coverage YAML as well?
Not yet. No, that's okay. So I don't see everyone with yellow stickers, but I see people already moving forward. So I'll just continue, and in case it's still not working, then please put the pink sticker on. So the nice way to do it would be if we want to introduce Travis, then let's say first we check out into a new branch. So that's a nice way to work so that you don't work on your master branch. How do I do it? Okay, I can. That's not a skill I have, but let's see. This works, okay. So then in our main repository, we want to add a list of instructions for our computer in the cloud that will do the tests for us. So it's typically done by providing a travis.iml file. So that's what we're going to do. And because we are at PyCon conference, then we're going to ask for a Python language to be available for us in this machine. So yeah. Then I'm going to ask for Python 3.6 to be tested with my test. You can later test if the same tests will work for Python 2.7. And then we have to ask, since it's a fresh, so the thing we're getting is a fresh Linux machine. And as I said, I think we're getting it for 45 minutes of us using the machine. There is a caveat to that. If your tests are not producing any output for, I think, 10 or 15 minutes, you will also be kicked out and your session will be marked as failed. So some use of print statements could just be print something out from time to time if your simulation is long, so that there is some action going on your Travis.
Also can change the settings
Yeah,
somehow.
yeah,
But
you can.
For example, like the reason why we are sometimes using Circle CI in our work, because for example, like there's like in terms of memory, it's hard to. Circle CI gives you different limit for time and for memory if you use something.
So after I asked for Python 3.6, I asked for additional packages that we need to run our simple example. So those are the dependencies that I have. And then the last thing I do is the script. So after this, Travis in the background will clone the repository you're testing, so you don't have to specify any instructions for that. And then the last one is the script you want to do. So for us, it's just pytest tests.
You can either use pytest or just pytest.
Yeah, whatever works. So if you have this file, we save it. And to the Git, we ask it to add the Travis file to our repository. And then we commit it with a very useful comment. And then we push it to our repositories.
This is not Git tutorial, so we don't want to go to details, but if you have questions, just ask.
Yeah, but that's like the typical workflow, I think, is you create a separate branch, you work on it, submit the requests to the main repository, and create a pull request, or at least that's one of the easiest ones to have. So once that is done, I go back to my repository. There is a new branch called @Travis. And I create a pull request from that branch to my main master branch. And it didn't work. Maybe I have to do this. Yeah, it did not, because I did not add this repository to Travis. So let's see if I have to create a new one. Probably I don't. So let's close this one and see again. No? Do you have it? Ah, okay. So do you have it? No. Okay. Okay, so sorry, I was trying to create a pull request to her branch. Now I'm trying to create a pull request to my branch, and since I set up Travis to be activated on my repository, so all things are fine. So you can see here that after some trial and error, after I create a pull request, GitHub automatically starts running my tests on Travis. And again, there are many settings you can have, so you can have your tests triggered every time you commit some changes to the main repository. You can have it on every new branch, or maybe on every pull request you create. So that's why here, right now, there are like 3 different instances of Travis running there in the background, testing the same thing. So that's for you to decide of how you want to use it. And then we can click into the details. And we can see the build itself. So we can see our, like sometimes here you will have on the left some of the things that Travis is running hidden in the background for you, so you don't like pollute your screen with installation comments from your machine. But in the end, what you will have is you will have all the tests being run on some machine somewhere else, and you will be able to see if the things are still green. So if all the tests are passing. So is anyone still not able to run her or his own instance of those tests?
She didn't expect that it would work.
Yeah. Is it working for you?
Be set up, like I can see in Travis that it's there, it's linked to my account.
Okay, and then if you go to, so here it's no repositories found for some reason. Can you try to add the plus and choose the PyCon test here? And if you just click on it,
And that's forked.
Forked from.
There are no branches for this repository, but I created a branch. Because if you look at this, so there it is.
Okay.
Right, forked from, created a pull request.
And here
it says no, it continues to have not been set up, but it has. But so I'm doing this on my personal, but I also am part of several organizations.
no, but that shouldn't. I mean, it's all open source, so it all should be working fine. Can you try to just like close this pull request and open it again? Maybe. I'm sorry if that's the only.
No, it's okay. It doesn't matter. It's just a. So.
Yeah, and then create. You go to code.
Let's just create a new one.
Create a pull request. Here, also our new pull request. And
Oh wait, we're in the
yeah.
wrong thing. Hang on.
Yeah, add Travis. And you create a pull request to your master.
Then I change this.
Yeah. Base master. Yeah.
Compare a Travis, right?
Yeah. And then create a pull request. Okay, yeah, so can we go back to the Travis setup? And again, I'm sorry, but I will ask you to log out and log in again because that would help us yesterday evening.
Right. So I'm signing in with GitHub.
Yeah, yeah. Okay, so I'm more hopeful now because it's here.
Oh, I see what you're saying. Yeah. Okay, so
So,
let's try another pull request.
Yeah, or maybe just refresh this one, and if that doesn't work, then
Refresh this one? Or refresh this pull request?
yeah. Either refresh this pull request or just close and open again. As you see, it fixed it just by signing out and in again.
Yeah,
So
it's a little weird, right?
yeah.
I don't want to merge it.
All right, just close it and again, and
Do that again.
yeah. Sorry.
Yes, sir.
Or maybe you can just reopen it.
I was wondering,
Yeah.
that's what I was thinking, like,
No,
No.
so it's
let's close it. I'm wondering if logging out and logging in again will
yeah, because
sync it on both sides.
I mean, I'm hopeful because now at least it shows along
On the
your
Travis
Travis active repositories, right? So
Maybe tell the rest of the people if they have that issue that they
Yeah.
should.
all right.
That's a bit
But
weird.
that's not from master, but you want to go from at Travis, yeah. Okay. No? Can I
To add something. So when you are creating a pull request on your GitHub,
This is exactly what I wanted to
it's
get out of
often
this.
like
Okay.
default
Just
is
setting
the
up
main
so
repository,
it
so it will be to me. So
Ah,
when you are
so
testing
set up
if Travis works for
tutorial.
me. So if you want to really
Oh,
like
it shows your
test your
open
own
source,
like
exactly.
repository, you should
That's what
change
it
the
should be.
in pull request that you are like
install for free.
creating to your
I think
master,
maybe it's-
and I can help you with this.
It may be messing up because I do have an organization account.
Could be. It's also that if you have Travis configured for a very, very long time, then it used to be done differently, I think, on like a GitHub Travis interface side. So maybe you kind of have to like reset it again.
Yeah, let's see.
Yeah, well, I mean, we tested it on 4 different laptops and got like 3 different outcomes from this
Right.
whole process. So that's why,
Oh, look, see what it's doing?
yeah.
But that. I mean, I'm going to grant
Yeah,
it,
yeah.
it's fine, but. I think it has to do with the organization setup because it's not.
Could be. Yeah.
There we go. So it's there.
Okay, so let's see again if it. You can just see pull requests here. Let's see if anything changed. Just like if you go click here,
This one?
yeah. And just see. Okay, so I would like again close and open it so that we trigger the Travis build.
Okay. Let's try again.
from at Travis. Can you go to the Travis account you have here? Or yeah, this one. And go to the PyCon test thing. And
It's not syncing. Because it should at least see the branches.
yeah, it should be, and it should see the.
And we have the environment variables, so I don't know. Yeah. Whatever this is doing, it's not moving.
Can you see? Can I see the pull request?
The
And the files that you're adding? Yeah, here, just here, click here, and then the commits here, or files changed.
So we have a ton. Because I dropped in all the solutions files.
Okay, and if just the Travis file that you have.
The YAML?
Yeah, the Travis file that you have in this commit. So if you go to the add Travis branch, and so it should have a dot in front of it, so it's dot Travis.
Yeah, okay.
Maybe that's why it's not recognizing it automatically.
That's probably it.
Yeah. Okay. This can be a more meaningful pull request with something actually changed.
What?
Okay, so
Yeah.
push.
Let's connect. Yeah, I did.
All right, and then see the GitHub account if it's find the pull requests. Yes, it's already working because I see this yellow dot. So if you go here, or you can just here, and you see the builds are.
Okay, so then how do you see the actual tests themselves?
So you can go click on any of those yellow dots, I guess, or yeah, here. Sorry, not on the head itself, but where are the tests? Maybe it's not refreshed if you like go back to the pull requests. Yeah, and here test Travis and details. Sorry, I thought the yellow dot would give you the same thing.
Yeah.
And then the build here.
Okay, that's
The build.
currently running.
Yeah, but you can still see the output.
Yeah.
So if you click it, you will see the. Once it loads, you should be able to see the build itself here.
Great.
Yeah, so it's still testing things, and at the end,
We'll see if my copy and pasting
yeah,
works.
if your copy and pasting skills are okay.
You know,
But
up to standard.
yeah, so then in the end, you will either see a green dot if all the tests passed, or a red
Right,
dot
right,
if
right.
it doesn't. Okay.
I think maybe it worked though.
It's just the proximity of the tutorial person. yeah, it's, I mean,
Okay, so I got the, I was just confused because I didn't get the, or, no, that was from earlier. I wasn't sure if I had like switched branches or something.
but it should be like here in your web browser, you see the end result is here. Like this is the build test, so it's, that was run somewhere else, right? So
Okay.
so it worked, right?
Okay.
Because this is not your computer anymore. It's some computer given to you by
Okay.
Travis. And
Okay.
then if you go back to your GitHub page and you go to this pull request thing you created. No, you didn't create any pull request? So how did you trigger the, or maybe if you just go to the code.
I added this file.
If you
Okay.
copy the Travis file from
Okay,
solution instead of writing from scratch,
Is that how it
you
Yeah,
have
I
to
mean-
change the name because Travis expect to have like .travis YML. So just to remember about this.
Yeah, okay, so now if you, yeah, it's because you didn't create any pull request, so the way for you to see it right now is to go to the Travis account
Okay.
and see it. The alternative would be to create a new branch. From that branch, create a pull request, and then that should trigger the same thing on Travis, but it should also show on your GitHub page as a report.
Okay, because like I checked out and I did like a new branch, but then
Okay, so what you can do,
Maybe I can help
Okay.
you and you can.
continue, okay. Okay, so at the end of it, hopefully, what you see as the end result is here. Not this. Okay. Okay, so what you want to see in the end is that when you create a pull request, either between your branches and a master branch or your branches and some other project you're interacting with, you get this additional box in your GitHub account that tells you that either all checks have passed or they did not. And you can follow that further and see the details of your run. So that shows you like some details of the machine you were running, what Linux distribution, things like that. And you can go even further. Yeah, you can go even further, and you will see exactly what happened in this machine you've been testing with. So if some tests are failing, and again, it's nice to have some print statements with your asserts so that you can actually see what things are going wrong in your Travis run. Okay, so that was one example. And maybe, yeah, you can specify the settings. As you have seen, for some of you, at least for me, it triggered 3 Travis builds, one for my pull request, one for my branch, and I think one for my main repo. So that's also to be handled in your settings when exactly you want to trigger your builds. I probably have gotten email notifications for my GitHub email, whether my tests are passing or failing. You can also integrate those notifications to your Slack channel and probably other things. And if you ever wondered how to get that nice badge that tells your builds are passing or not and have a green tick box next to it, then you have to add this thing to your README file. But just remember to check your GitHub account and your repository name so that everyone else knows you're running your tests on GitHub. Another feature that maybe we won't spend time configuring because it takes time, but if you want to do it, then talk to us after the tutorial, is the CodeCov package or app that you can integrate with GitHub. So it's a similar process. You go to the CodeCov website, you create an account, you sign up with GitHub, you specify which repositories you want to be covered with CodeCov, and then you update your travis.yml file with additional line to install CodeConf and PyTestConf, and you have to have some more complex syntax to specify where to save the output of the CodeConf. But the main idea is that the CodeConf app automatically tests, like sees when the tests are running. It sees what parts of the code are tested by the tests and what parts of the code are not covered by the tests. So at the end of it, you will have some report saying, I don't know, 32% of your repository is being covered by the tests, or maybe 95% of your repository is covered by the tests. And also because it's triggered, or it can be triggered on every pull request, you will have a report from CodeConf saying this new request actually decreases the test coverage of your whole repository. So maybe that will be an information to encourage your contributors to have more tests, so that if they're introducing new features to the code, you kind of automatically check if those features are already being tested when they are brought into the main repository. But we won't do the whole setup by here. But again, later, if you want it, come to us after the tutorial and we'll do it. And again, you can have a nice fancy badge on your README file that shows other people how much percentage of your repository is covered by tests. And someone asked about the external resources. So yeah, software carpentry, it's one place to go. This Python testing book that Dorota mentioned before and the blog are here. A book I read at some point was Obey the Testing Code, which is more for web app developing, but I think the first 2 chapters sell you maybe in a different fashion on the idea of how to test code. So if you are curious of what is the testing code, then I encourage you to check there. And we also would like to thank a person who created this nice test or tutorial on how to create animations with Matplotlib. So thanks are there. So to maybe slowly start to summarize, because in the end, we spent a lot of time on unit tests, and we all appreciate the fact that they are easy, and the fact that they are easy is no excuse for not doing them. It should be a reason to do them in big variety. But of course, the unit tests are not enough, and again, since we come from a scientific computing background, then when you're finished with your unit test, you will probably end up very often doing some regression tests, or you comparing with other publications. So I have some example here. It uses somewhat Python, but also C++. But here you have a nice GitHub repository, which actually tells you that the code in this repository reproduces some figures from section 5 of some paper, which is the purpose of testing. Like basically here they are developing a new transport algorithm, so you want to make sure that whatever features people already achieved in transport algorithms are preserved here. You have some README, and you have a way to run the tests. That's, for example, in computational fluid dynamics, there is a big variety of tests that you can use to make sure your transport solving schemes are converging correctly. I work on cloud microphysics. There is really no ground truth. People really don't know yet how things should be in the clouds. So sometimes the only thing you can do is just test. If you manage to submit and publish a paper, then maybe you just want to have some automatic test that from time to time, or maybe when you change things, sees if you can still generate the same figures you have published in the year 2015, and if the test results and the convergent results and I don't know, the final temperature of your cloud is, and by cloud I mean like clouds in the atmosphere, not cloud, yeah, should have said. So if the final temperature of your actual cloud is the same as it was in the year 2015. And on one hand, it might look silly that that's the only test we can write, but if you think about it in a different way, wouldn't it be nice to be able, with one command line, generate all the results and tests from your previous publications? And wouldn't it be nice to know that they actually are being generated from time to time on some computer and they are still there and they are still the same after 2 or 5 years? Or maybe when they stop being the same, you're the first person to discover it and you have the time to do something about it, or at least try to understand what changed. So in general, if you have a scientific code and then someone tells you, okay, write the tests to it now, then I don't want to say it's too late, but it's definitely a very challenging thing to first have the whole code there and then be tasked with writing tests to it. So it's really about writing your code and tests in parallel. The purest way would be to start with a test that is not working and then build to the time when the test is fixed and you have a code that works. But if you don't have to be purist, but in general, the way I work, like I simulate my clouds and then maybe I plot a profile of cloud water and rain and wind in my atmosphere. And then at some point, I just want to keep that work and keep that plotting script and turn it into a test and have it checked every time when I change my code. So yeah, if you write some script to visualize things, then think if you can turn it into a test, and definitely automate so that it's not your choice whether this change is big enough to deserve being tested. It's really done behind your back by someone else. And remember that no matter how many tests you add, it's still not going to be 100% certain your tests are as smart and as good and as cautious as you have been in creating them. I would say sometimes it's really more difficult to write meaningful tests than to write the code itself, especially if you're the person that both codes and write the tests, because kind of in your mind you know how it should work, so you're not expecting different inputs or I don't know, different simulation scenarios. So it's very helpful to have other people test your code and like work as a bigger group. If you don't have that privilege and you're working in a small group or by yourself, then yeah, please have in mind that even if you have a page full of tests that are passing, they are as good as you have made them.
But even if you are like the only user at the beginning, you might think that one day you might have like bigger group of users, so be prepared.
Yeah, so that's it. And maybe before we go to conclusions, those particles colliding, we thought it's a good example because it's very easy to abstract away the complexity of many particles moving into 2 particles colliding in 1 dimension and 2 dimensions, and then maybe 3 particles and so on and so forth. But try to think about the projects that you're working and see if you can build those. If you can build those small components and small like blocks of code into tests and see if at least for some components of your big scientific projects, you can have that nice simplicity in your tests.
So we have like 10 minutes for discussion and questions, but also like I put the link. Can you go to the pad, the Etherpad?
Mm-hmm.
I put the link to the server that is at the very bottom. So yeah, this is like run by PyCon. So please fill it.
But if you also want to share some comments with us, then
yeah,
you can just write them there. We can take it.
Or remove it just after 5 minutes.
Remove it.
But yeah, please.
Also, like I don't know what tests you put on Travis, but Dorota checked my regression test, and for her it failed very quickly. So yeah, maybe we can show that also. But yeah, if you have some questions or comments, or in general you want to share what is your scientific project that you're working, and maybe discuss with other people what tests they did for a similar thing, or I just want to show that this. Oh. Okay. No.
changed something and now it's working. So
All right.
oh, maybe. Sorry, I've been like editing my report.
All right. Yeah.
So you two seem very passionate about testing. As somebody who works with a large group of scientists who sort of are on different parts of the spectrum, how have you gotten, and feel free to also say we don't have this issue, but like how have you gotten other team members on board with this approach?
For me first, I think for me the best experience to showcase is that if you're joining a new project that doesn't have such a test workflow built in, and you're a beginner, right? And you create some pull requests. And maybe it's stupid, but on the other hand, you just joined the project and you're really excited to have it there merged, right? And then it's not merged because the person who's responsible for reviewing the code is like, maybe there is a publication coming up soon and you really don't want the code to work badly because of some stupid new person joining the team. So I think for me, the angle is really building the confidence so that you can change the code and other people can change the code. So that in general, you can integrate other people's commits faster. If you're working just with yourself, then again, it's the confidence to dare mighty things in my code so that I know I don't destroy everything I have achieved.
And also like during my PhD and postdoc after my PhD, when we were in the same group, I think we just found like enough, I mean like 3 people that were willing to do this. And I was already like, after like 5 years of PhD working with code that didn't have any tests. So I was like motivated. Also like sometimes discover like these conferences are great because you also see people outside science, yeah? And sometimes you actually realize that, like other people are using tools that you've never heard about. And yeah, in my previous group was like this, that we have like enough people, like with Anya and one more person, that we kind of started doing this, and we kind of like kept motivated each other.
Another thing is like, if it's a scientific application, then for sure at some point you're creating a plot of something. The least you can do is when you publish it, turn it into a test and check if it's still there. I mean, it's about reproducibility of your research in general. If you don't do it, it's about building confidence in your research and showing other people, you can download the code here and you can run the code like this and you can generate the figures like this. And you can do it easily with just providing your GitHub, your Travis. And by adding Travis, you also specify how to build the whole scientific repository on a clean Linux machine. Things can still break if, Python packages are updated or the language versions are changed on the Linux machine, but it's still...
The whole idea of writing tests is that they are breaking, from time to time. So it's like, basically also like more and more scientists, I think, are doing this. So like in my new group, my boss is, I joined a group that already was working on software, on open source software, and that is used by like hundreds of people. So it's like, at some point you just cannot deal with big project without tests. So, I think like more and more people even in academia are using. So yeah, you can be first one in your group.
How do you, if you have a large data file, like a couple of gigs that you need to read in to run a test, how do you handle that through Travis?
From Travis' perspective, you also like might be too big for Travis. Maybe you have to use like CircleCI in terms of loading the file. I don't know exactly what you want to do, but in terms of like the problem is that you are not storing big files in GitHub. That's the main reason. So actually, like one of my colleagues is actually working on projects that is like Git Annex and Datalot. I don't know if you ever heard about it. So Git Annex is based on Git, but it's exactly, it was developed thinking about like big files. And it's actually really cool because, as you know, some of you at least know that Git will like copy the file to every single locations. Like Git Annex will be smarter and it will not copy the like every time you upload directories. And data is like Python package on top of this, and I'm happy to share with you this. But yeah, that's true. Like sometimes you cannot. I mean, also sometimes you can download not the entire file, but maybe some statistics, yeah, and only compare some statistics. But I see what you mean, yeah.
On that, so at our company, we had a big issue with big data files, and the guys actually built a method to create specific mock data for that to compress smaller things, because how much data?
So we do a lot of mocking because we load a lot of big time series data. So we usually, after we develop the method, we make mock testing classes so we can generate fake data on the fly.
Yeah, the fake data are also like good, but yeah, if you really want to store big files with Git, you can do it, but just use like Git Annex with this. And you basically, what you like publishing on your GitHub account, it's not the data itself, it's just the sibling, so you can find it. So once you push in like a repository that is like publicly available, you can do it.
I mean, to follow up on the science application, another discussion we had at some point was that, I mean, all of this works for open source public repositories. We had to have some pushback from time to time from professors saying that, you know, this research is not published yet as a paper, so why would I want to publish my code before I do that? Someone can take it before I publish it professionally as my paper. So that's another discussion you might face with your boss.
But if you cannot, you cannot. But you can always like have it private, start as a private project. Some of the tools will not be available for you if it's private.
Or
you
they
might
will
have
be
to wanna pay.
if you pay. Right?
Yeah, but after you publish, you can just make it public. Yeah. Around like for the conference, so if you have like any questions, you can email us and we can, like meet and talk more.
Yeah, and I encourage also you to check out the code cove. There are also other features like there's Codacy. I think that will check your syntax. So if you have some parameters that are defined but never used in your functions in the code, then Codacy will generate a report to GitHub page complaining about that. Yes, I encourage you to check out all the different applications that are available to you on GitHub. And there was a question.
You mentioned two additional things to take a look at, Git Annex, and what was the second one? Datalot?
Yeah, it's Datalot is, can you actually open datalot.org?
Mm-hmm. Like this?
I don't see it. No, D at the end.
Maybe you can type it?
Yeah, sorry. So this is the project that is based on Git and Git Annex, and I'm now from your scientific community. So it has like many things, many available data sets from this community, but it's like general purpose tool, so you can use for whatever you want. And this is also has like Python wrapper, so you can so you can publish your data without actually like pushing like 50 giga somewhere. Obviously, GitHub will not even allow you for this, but yeah. Pretty cool, not only for testing, but in general about like sharing your data. It's perfect tool. Also, you can have like some data in one location, the other data in other location. It looks pretty cool. And I will add the link to the slides, so just so you have like later. Thank you.
Can you use it to share SQL databases?
I'm not sure. So. You would have to probably like write something the way so it's able to discover. because like I understand that you are also asking not only if you are able to share, but if you are able to search in meaningful way. To
Yeah, well, a lot of times you have a SQL database and you've done the research, the project's done, but you want to archive it so other people can download that SQL.dump file and
Yeah.
reproduce the work.
I'm not working on this, so I'm not completely sure actually.
Yeah.
So yeah, I mean, I can check. I mean, you can you can email me, and I will come back to this. Any other questions?
All right.
Thank you.
Thank you.